Today we're going to learn about piecewise and step functions. This covers Common Core benchmarks FIF 2.4, 2.6, 3.7, and 3.9. The objective is that you'll be able to graph piecewise and step functions. First, we're going to look at absolute value as a piecewise function. We have graphed the absolute value function y equals the absolute value. As a piecewise function, it becomes f of x equals negative x when x is less than 0 and x when x is greater than 0. These equations can be looked at as a linear equation, y equals negative x, but it's only used when x is less than 0. So if we look at x is less than 0, we would start at the 0, and because we have a negative slope, we would go up 1 and left 1, up 1, left 1. And these are for all the x values that are less than 0. So if you were to make a table, then you would use only x is less than 0, which would be negative 1, negative 2, negative 3, and so forth on. And you would plug into y equals negative x. So these would give you the values of negative 1, up positive 1, positive 2, and positive 3. And so we plot those points, and you can continue on with it. Then we look at the second half, which is f of x equals x. That function is like y equals x, and it's used for when x is greater than or equal to 0. Since we want greater than or equal to 0, when we make our table, we're going to use 0, 1, 2, 3, and so forth on. And you're going to plug into the function y equals x. So you would get 0, 1, 2, and 3. Then you plot these numbers for the other half of the graph, and you see you get the V shape, which from what we learned in absolute values is what the graph should look like. The domain of this is all real numbers. Because I want numbers less than 0 and greater than or equal to 0, I can pick all real numbers. The range is when y is greater than or equal to 0. So let's look at another piecewise function. Graphing a piecewise function. Here we have two different functions. We have the function y equals negative 2x when x is greater than y, or y equals x plus 3 when x is less than or equal to 1. So if we look at the numbers negative 3, negative 2, negative 1, and 0, when the numbers are less than or equal to 1, so we go up to 1, we will use the function y equals x plus 3, in this case x being negative 3 plus 3, which will give us 0. Then we would do y equals negative 2 plus 3, which gives us 1. Y equals negative 1 plus 3, which gives us 2. Y equals 0 plus 3, which gives us 3. And y equals 1 plus 3, which gives us 4. I use this function because we use x plus 3 if x is less than or equal to 1. So as long as x is less than or equal to 1, I'll use the x plus 3 function. Now, when x gets greater than 1, I would use the top function since it says negative 2x if x is greater than 1. So for all x values greater than 1, I'm now going to use negative 2x. So I would say negative 2 times 2, which is negative 4. I would say negative 2 times 3, which is negative 6. And I would say negative 2 times 4, which is negative 8. Now because the values start at being greater than 1, I have to do 1 and say negative 2 times 1, which is negative 2, and I would start with an open circle because it is greater than and not equal to. So to graph this, I'm going to graph negative 3, 0 with a closed circle, negative 2, 1, negative 1, 2, 0, 3, and 1, 4. Because this function happens when x is less than or equal to 1, we would start at the x value 1 and we would go less than. And because we can keep going less than, you would draw an arrow on the end of it because that function can continue as long as the x value is going less than 1. For the other half of the graph, because this one starts when x is greater than 1, we evaluated at 1. So 1 was -2, but we're going to use an open circle because we only want greater than 1 but not equal to 1. And then we plot the rest of them that we evaluated, which is 2, -4, 3, -6. Let's go back here. 2, -4, there we go. 3, -6, and then since -8's not on here, we'll leave that dot off. But we can keep going, and so we would draw again an arrow at the end of that line. Because x is greater than 1, I could keep picking numbers greater than 1 and my line would continue on. So a piecewise function is just two functions that start at a specific point and then keep going in one direction only. And it's two functions in one instead of just one function. Graphing step functions. Step functions are also known as the greatest integer function, and they are symboled by, or shown by this symbol here. And what this means is it's like a piecewise function, but you only do integers, you don't worry about decimals. So let's look at how to create the table of values. So when I use -2, I'm going to say -2 plus 2, and I would get 0. If I do -1.5 plus 2, I would get a decimal, but I round it up to the greatest integer. So since that would give me a 0.5, I round it up to 1. Then if I do -1 plus 2, I get 1. Then if I do -0.5 plus 2, I get 1.5, and I round it up to 2. If I do 0 plus 2, I get 2. If I do 0.5 plus 2, I would get 2.5, which I'm going to round up to 3. 1 plus 2 gives me 3. And so what ends up happening when you make the graph is if we start at -2 with a closed circle, then I would go up to the next one with an open circle to 1. So anything between -2 and -1 has a y value of 1. And then you go up to the next one, and anything that has a y value between -1 and 0 goes to the value of 2. Because everything gets rounded. And then you keep on moving up. So anything between 0 and 1, 0 starts at 2, and then anything after 0 gets rounded up to 3. So anything between 0 and 1 gets rounded to 3. Anything between 1 and 2 gets rounded to 4. As you see here, 1.5 plus 2 is 2.3.5, and it will get rounded to 4. And then 2 plus 2 is 4. And so it creates these little steps, and then you can work backwards. So anything between -2 and 3 will get rounded to 0, but -3 will become -1. And then you can keep working your way down or keep working your way up. And that's what a step function looks like. It only looks at integer numbers and does not include decimals. So let's take a look at a real-world example. Cell phone companies charge by the minute, not the second. A cell phone company charges 45 cents per minute or any fraction thereof for exceeding the number of minutes allotted on each plan. make a table and a graph that represent this situation. What ends up happening is between 0 minutes and 1, it gets rounded to 1 minute, charging you 45 cents. So if we continue this pattern, what's going to happen? Starting at 1, anything greater than 1 but less than or equal to 2 will get rounded up to 2 minutes, and you'll be charged 90 cents. See if you can continue on with the table and then make your graph based upon this. Remember that you can make your graph how you need it to be, so you can label this 1, 2, 3, so forth on for your minutes, and then for your money along the side, you can make the axis however you would like to fit your numbers. Continue this on and then bring this into class the next day, and we will go over this and see how you did.